The new generation of technology. The new generation of information. They bring the future for us. Institut Teknologi 10 November. A place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. Mostly the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSYS, Vocation, Creabis, MarTech, Electrics, SIFPlan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and robotics, automotive, maritime, and creative industries. Therefore, the excellent generations from ITS will emerge and make history. ITS is a space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS, the University of Heroes. The world keeps evolving. The times keep changing. The new generation of technology. The new generation of information. They bring the future before us. Institut Teknologi 10 November. A place where the spirit of heroism underlies the new generation to research and innovate in technology. The University of Heroes, ITS. ITS is one of the best science and technology universities in Indonesia, which was founded by Dr. Angga in 1957. In every step, ITS focuses in advancing education, research, management, and community service. As an incorporated public university, ITS has been able to manage autonomously the policy of academics, organizations, finance, students' affairs, human resources, facilities, operational, and infrastructure.
In the spirit of Indonesian heroes, during the battle in the 10th of November 1945, ITS always makes efforts to be the best in education, research, and community services, especially in the fields of industry and maritime. ITS also actively contributes to the nation development, and in the future, ITS will become an entrepreneurial university with world-class reputation.
ITS has many achievements. Both national and international achievements prove that ITS keeps growing and gives the best contribution to the nation of Indonesia. ITS is a place for new hopes to grow. An ideal environment for the new generation to flourish in 3 strategic locations within the industrial city of Surabaya. As a smart eco-campus, ITS maintains harmony between technological advances and the sustainability of the surrounding ecosystem. ITS has 7 faculties with prospective scientific fields, including Scientics, INSEE, Vocation, Creatis, MarTech, Electics, SIFPlan. ITS is a space for the new generation who are hungry for knowledge because it provides a wide range of references in both physical and digital form. ITS makes it easier for the new generation to access information by providing flexible classes. ITS keeps moving forward in facing future challenges by providing the best facilities for the new generation's activities. The facilities support both spiritual and physical needs. ITS also provides research facilities in the ITS Science Technopark, including ICT and Robotics, Automotive, Maritime, and Creative Industries. Therefore, excellent generations from ITS will emerge and make history. ITS space for the new generation to express themselves. ITS is a place where the new generation learns new things and finds their purpose. ITS has become a place where the new generations that carry the future will be born.
ITS is a campus of science and technology, which focuses on the research and innovation, presenting technology for prosperity.
With a spirit of heroism, ITS brings the future before us. ITS University.
Distinguished guests, ladies and gentlemen, before we start commence the program, and here are the following webinar protocol. For each participant ID, please use your real name following with your origin of institution. All of participants are expected to mute the audio and only unmute the video during the event. We cordially invite you to take your own firm and comfort seat in your own room, and please avoid the backlight. Make sure that you have a good and stable internet connection. If you have an earphone or headset, we recommend you to use it so that your voice can clearly and loudly to be heard. During the Q&A discussion session, all participants, please use the chat box to deliver the questions. Thank you for your cooperation and consideration.
Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. Welcome to guest lecture series on SDGs today, Wednesday, 17th of March 2021. My name is Tamara from ITS Global Engagement and will be your master of ceremony this afternoon. Thank you for joining our guest lecture series on SDGs. Before we start our agenda, let me inform you of some rules for the event. First, please fill your attendance at bit.ly/attendance_GLS SDGs. Our committee will also send the attendance link in the Zoom chat room. For participants who wish to get an e-certificate and stamp for it, please fill the attendance 15 minutes after the session starts. Next, participants who wish to ask questions during the question and answer session, please send your question to intip.in/Q&A/GLS SDGs. The link for questions will be listed in the chat room as well. Or you can ask directly by clicking the raise hand feature. Ladies and gentlemen, today's guest lecture series on SDGs theme is Ensure Sustainable Consumption and Production Patterns and Rethink of Plastic, which will be delivered by our speakers, Dr. James McGregor from University of Sheffield and Dr. Warmadewanthi from Research Center of Infrastructure and Sustainable Environment ITS. This lecture will be moderated by Ms. Ainul Firdatun Nisa, Master of Science from ITS. Before we start our agenda, allow me to deliver our schedule today as follows. First will be the opening, that will be followed by introduction to moderator and speakers. Next, we will proceed to the lecture session, followed by Q&A session. Then we will proceed with the certificate awarding, and last but not least is the closing. Now, before we proceed to the next agenda, let me introduce our moderator today. Our moderator today is Ms. Ainul Firdatun Nisa, Master of Science from Research Center of Sustainable Infrastructure and Environment ITS. Her educational background is Master of Science from University of Stuttgart, Germany on 2019 and Bachelor of Engineering in Environmental Engineering ITS on 2015. Her current position is as a lecturer and researcher and the Department of Environmental Engineering ITS. She has several professional societies such as IAHR, Susana RWSA, and also Research Center for Environment and Sustainable Infrastructure, ITS Surabaya. Now, without further ado, let us proceed to the main agenda. To Ms. Ainul, the time is yours.
Great. Hello, everyone. I hope you hear my voice clearly. Great. Thank you, Samara, for the nice introduction. So, good afternoon, everyone. Good morning if you are now in Europe, and good evening if you are now in Australia. So, welcome to the guest lecture series conducted by the Institute of Technology 10 November, Surabaya. My name is Ainul Firdatun Nisa. I'll be moderating for our session today. So today we'll have two great speakers. The first we will hear a lecture from Dr. James McGregor, and then the second one we'll hear the presentation from Dr. Warmadewanthi. I will read out a little bit information from Dr. James McGregor. So he's a senior lecturer in University of Sheffield, and he holds PhD in heterogeneous catalysis from the University of Cambridge. And his research areas covered span of CO2 utilization, biomass conversion, and also energy materials and petrochemical processing. And the next speaker is Dr. Warmadewanthi. So she is the head of the Research Center of Sustainable Infrastructure and Environment at the Institute of Technology 10 November. Her background is the Doctor of Philosophy from the National Taiwan University of Science and Technology in Taiwan. And she is also a senior lecturer at the Department of Environmental Engineering at the Institute of Technology 10 November. And her research expertise cover solid waste and also water and wastewater treatment and management. So without further ado, I will hand the first session to Dr. McGregor. So yeah, Dr. James McGregor, the time is yours.
Thank you very much. And yeah, good afternoon, good morning, good evening to everybody. Thank you for joining. I'll trust everybody can hear me okay, unless I hear otherwise. So I think without further ado, I will just make a start with my presentation. So let me just hopefully share my screen. So hopefully everybody can now see my slides. If someone on the committee can just nod to confirm that for me, that'd be good. Good, excellent. So yeah, as you heard, what I'm going to talk about today is in terms of related to the SDGs, it's going to be looking at sustainable consumption and production. Before I start, I will just give a very brief recap of who I am and where I'm speaking to you from today. So as you heard, I'm a senior lecturer at the University of Sheffield in the UK, based at the Department of Chemical and Biological Engineering. So my background, I have a master's degree from the University of Edinburgh, a PhD from the University of Cambridge. As you heard, I also spent some time briefly at the Fritz Haber Institute in Berlin as a guest scientist. I'm also a chartered engineer, particularly a chartered chemical engineer, as you might imagine. In terms of what my research interests are, obviously I do obviously an element of teaching on our course as well, but in terms of my research, it is in the field of sustainability, particularly sustainable catalysis. So the sort of things my research group will look at will be the application of waste products or low-value co-products as feedstocks to make the sort of chemicals and fuel products that we currently largely get from fossil and other less sustainable sources. So that's who I am. I'm coming to you today from Sheffield. I have a picture of Sheffield on the wall behind me. This is the view of the city from the train station that greets arrivals into Sheffield. If you don't know much about Sheffield, the slide on your screen shows you at least geographically where it is. It's pretty much right in the centre of England, right in the middle here. So it's about 50 kilometres east of Manchester, about 2 hours from London by train. And you can see some of the scenes of Sheffield, the theatre district, some of the countryside around Sheffield. It's a very, very green city, the greenest city in Europe with 2.5 million trees in the city. So it's a very environmental city. It's also where the oldest football team is based, among other things. And it has a very, very long history of engineering and development. So for instance, it's where stainless steel was invented and ultimately commercialized and so on. In terms of the university, this shows an area around the central university itself. So the red building on the left is one of the main university buildings. So this is where some of our administration, where biology and other departments are. Chemical engineering is just a little bit further off to the left of this picture. But you can see other university departments and the sports facilities here. There's a large museum in the centre of the picture in this part. I'm actually sitting at home, just up on top of this hill, off to the right of the picture that you see here. A lot of the buildings you see over here, the hospital in the city and so on, and the city centre, just a short walk to the left of this picture as well. So it's very, it's located very centrally in the city, next to where people like I live, with good access to, as I say, the centre and the rail connections and things like that. So that's who I am and where I'm speaking to you from today. In terms of what I'm actually going to present in the next 35 minutes or so, I'm going to introduce what sustainable production means, at least what it means to me and what it means to us at Sheffield. I'm going to tell you how chemical engineers can tackle the challenges of the sustainable production. I'm then going to give you a little bit more detail on some specific case studies there, based particularly on research within my own research group here at Sheffield. And then I'll say about actually how we actually equip chemical engineers to be able to tackle those challenges through teaching. So this is something I imagine most of you are reasonably familiar with. This is actually just taken off the UN website. This is what they mean by sustainable consumption and production in terms of the Sustainable Development Goals. So you can see some of the highlights here, where really it's highlighting that the world continues to use natural resources unsustainably. So you see on the right-hand side, the growing global material footprint that mankind is currently using there. But what that means in terms of, I mean, sustainable consumption production is potentially a little bit of a nebulous term, but you can see some of the specifics here. It covers things such as the unsustainable use of the fossil sources, which of course are finite reserve, which are declining, and of course contribute directly to climate change through their combustion and the emission of carbon dioxide and so on. It also covers things such as making materials and then simply throwing them away and not recycling them, not reusing that material, not going down the road of the so-called circular economy. So you see the highlight here being electronic waste, which continues to grow, but most of which is not recycled. And then finally, at the bottom of the screen, you see something that I guess is most easily associated with the idea of production, which is more on the agricultural side. So going all the way from growing and harvesting crops, through storing them, through those going to the end consumer. And at all stages of that, you see there's significant wastage. So there's crop left in field, there's stuff that gets wasted before it goes onto the shop shelf. And then there's stuff that people actually waste at home. They buy food, they don't consume all of that. And you can see that 13.8% of food is actually lost throughout that supply chain. And it's things like this that are unsustainable. We want to make sure food is not lost. We want to make sure waste is recycled, and we want to reduce our reliance on fossil sources. And all of those feed into the UN Sustainable Development Goal around this area. So that's what the UN means by it. At Sheffield, we have our own sustainability strategy at the university, and we're very much concerned with the three angles of sustainability, not just environmental sustainability, but making sure sustainability encompasses social and economic concerns as well. So a process or product can only be sustainable if it is environmentally, socially, and economically sustainable. And the social angle there is very important, making sure there is also a focus on people, that we don't go down a road that is actually disadvantageous and makes life difficult for our population, particularly the poorest in our society. And as you might imagine, there are very much tensions between these different angles of sustainability. But overall, the goal of Sheffield is to become one of the most sustainable research-intensive universities, and indeed I'll do that through aligning our research and teaching with these sustainability goals. And to that end, we actually include sustainable development as something that is embedded in all of our taught courses at Sheffield. So that is just an introduction to sustainability. So we all know what we're talking about when we talk about sustainable production and consumption. So how do chemical engineers actually tackle these challenges? So it's probably worth saying what chemical engineers do, because I know not everybody is familiar with actually what a chemical engineer is and what they do. So chemical engineers design processes to produce, transform, or transport materials, but also energy. So what they're doing is taking raw materials, whatever that raw material is, and turning it into the products we use every day. So be that food, be that pharmaceuticals, be that materials, fuel, or as I say, energy. It doesn't necessarily have to be a physical product, but something like energy would very much count there as well. So what they're doing is taking their fundamental scientific knowledge, and that's knowledge that's generated by and in collaboration with chemists, biologists, physicists, and so on, and taking that knowledge but applying it to real-world practical problems. So there's very much a top-down approach of identifying a problem and dipping into their scientific knowledge to solve that problem. So the sort of things, the questions a chemical engineer might be asking themselves are things like what reaction pathway should be used to make a product, how they can control the process, and make sure that it's safe, because safety is clearly something that's very much a top priority at all times. Also need to make it cost effective. There's no point having a wonderful process if it costs more to actually make the product that you can actually get from ultimately selling it. But then, of course, coming back to this idea of sustainability, we want to think about things such as how we can recycle energy and so on within the process. So we might think at things such as, in terms of the problems we're looking at, it's the sort of grand challenges that are facing society, things such as climate change, where chemical engineers are looking at processes to reduce emissions, so developing processes that, for instance, emit less CO2, developing clean fuels to replace those that we currently have from fossil sources, and ultimately decarbonising the economy, or at least defossilizing chemical manufacture and so on. Another grand challenge that chemical engineers are concerned with addressing is looking at health in the ageing population. So obviously globally, the age profile of the population is getting older. So they'll be looking at developing new ways of manufacturing at scale, things like pharmaceuticals. So of course, chemical engineers have played a very major role in, for instance, the development of COVID-19 vaccines. They'll also look at medical components and actually agrochemicals, so we've got the right sort of food and enough food to feed this ageing population. I've already touched on the idea of natural resource constraints, so diminishing supplies of key feedstocks, but again, that's a big question that chemical engineers tackle. So for instance, looking at alternative renewable energy sources to replace fossil energy sources, how we recycle. So we're not just taking lithium or cobalt continually out of the ground, where actually once that goes into an electronic product or a catalyst or something, we then recover that and reuse it rather than mining more of, again, a finite resource. And of course, making more efficient use of the limited resources we have. Finally, in terms of the sort of grand challenges that chemical engineers will focus on, the last one is urbanization, population growth. I mentioned global population is aging. It's also moving from rural areas into urban centres, into cities in particular. And of course, the global population continues to expand. And that brings with it challenges. So it brings with it challenges around waste, which we'll touch on later on. And I've mentioned plastics here. We've got a large project being led by one of my colleagues in the department at Sheffield, which is looking at reducing single-use plastics. I'm not going to say too much about plastics today because I know my fellow speaker is focusing on plastics, so I'll leave that for them to focus on, but that's also something that we have a large interest in at Sheffield. But other things we need to think about when people move into cities out of rural areas is how we make that environment healthy for them. So looking at things such as water treatment, limiting automotive emissions, so where actually the air is as clean and healthy to breathe as it possibly can be. And the technical challenge of that, that involves a chemical reaction. How do we get rid of those pollutants? And that is something that chemical engineers are at the forefront of tackling. So because of that, chemical engineers are very much in demand. They work all over the world. And as hopefully you've picked up on, they work in every industry in terms of manufacturing, but also go in and work in other sectors such as finance, consultancy, management, and so on. It is a very well paid job in terms of when you compare it to other undergraduate degrees. And most importantly, chemical engineers really do make a difference to these global grand challenges such as climate change, sustainability, urbanization, and so on. Okay, so that is the sort of things chemical engineers can do and tackle and address in this field of sustainability. So I said I wanted to give a few case studies from our own research within my group, and I'm going to talk a little bit about, to some extent, this idea of recycling, of the circular economy, with a particular focus on some elements of the agricultural supply chain that we mentioned. So going all the way from this idea of there being wastes left on the field all the way through to domestic food waste from your home kitchen. So I'll focus on various areas, but that will be a thread that ties it together. So among the things that we look at in terms of waste product utilization in my group are looking at things such as taking CO2 as a waste and going, well, can we use the carbon in that to make some of the products that we currently get from fossil sources? So I'll touch on that, but I'll spend a little bit more time talking about the production of liquid and solid products from food and agricultural wastes, either through sort of things that look very much like chemical conversion methods, but also through other approaches, such as actually using black soldier fly larvae, so maggots, actually as a reactor to convert some food waste into some chemical products. So that won't mean a lot to you just now, but I'll say a little bit more about that as we go through the rest of the presentation. So let's start all the way, right at the beginning of this agricultural supply chain. And when we're farming, we need fertilizer. Something that's hugely important in agriculture, but it currently is very energetically expensive to produce and hence has significant environmental consequences. So you can see that it produces 2.6 tons of CO2 per ton of ammonia. So ammonia is the key product that's going into our fertilizer and providing nitrogen for our crops. 2.6 times as much CO2 is actually produced as the amount of the ammonia that we're producing. So we're getting more carbon dioxide over the life cycle of that process than we are the product that we want. And ammonia production is actually consuming 2% of global fossil fuel each year. And the reason predominantly for that is that it relies on the steam reforming of natural gas, so taking methane and splitting that to get the hydrogen that then goes into the NH3 of the ammonia. So one thing we've looked at Sheffield is how we make this process more sustainable, how we can use waste materials to go into this rather than relying on taking methane out of the ground and so on and so forth. So this is the conventional method of making ammonia, where we take methane, we break that up to form hydrogen, and then react that with nitrogen to form ammonia. You can then make other fertilizers. You don't have to use ammonia directly. You may want to use urea, which you can then react with CO2. So you can take ammonia, react it with CO2 to form urea. What we've been looking at is a slightly modified process here. So rather than starting from methane to get our hydrogen, we can start from water. So we don't have to take this out of the ground. We don't have to put lots of energy into splitting the methane, but we can take water, convert that through electrolysis rather than steam reforming to get our hydrogen. We can then take nitrogen, which we can extract sustainably from, so you see swine manure here, that contains a lot of nitrogen, which otherwise would go to waste. Take nitrogen from that, react it with the water, the hydrogen that comes from electrolysis to form ammonia. We can then capture carbon dioxide, and that can be done from the air, but it can also be done from an emitting source, you know, a power source or a chemical plant or so on. So actually stop carbon dioxide going into the atmosphere as an agent for climate change and actually use it as a reactant. So we're reacting carbon dioxide here with the ammonia that's formed from ultimately our water and our manure to form urea, which then acts as a fertilizer. And this has been demonstrated at relatively small scale, but that's good. That means we can actually make fertilizer locally on an individual farm without actually having to ship it from a central facility. So we have this decentralization of production here where our fertilizer is being made locally. And you can see some data here that shows the urea that we synthesize via this more sustainable route performs at least as well as current commercial fertilizers. So that's one way that we're trying to make sort of more sustainable production, in this case, sustainable production within agriculture. Now, of course, we also mentioned that once you grow your crops, then there's lots of opportunity for food waste after that, either residues left in the field post-harvest all the way down to actually, you know, through stuff not going on shop shelves through to people wasting it at home. And the World Health Organization reckons there's around 1.3 billion tons of food waste produced per annum. So this is really quite a significant problem. And you can see some other stats there relating to the UK and the percentage of all avoidable waste that food waste wakes up. So it is a very, very significant problem. Alongside the challenge of food waste and how we deal with that, indeed organic waste generally, we're also facing other challenges in sustainable production. As we know, fuels and chemicals are currently largely derived from fossil resources such as oil and gas, but other key feedstocks that go into chemicals manufacture include things such as palm and coconut oils, which aren't fossil sources and to a large extent are renewable, but a lot of the agricultural practices are not very sustainable. So they have very monoculture environments that lead to a loss of biodiversity and other type problems there. So we've got lots of challenges in where we currently generate fuels and chemicals from. So the utilization of waste resources rather than these fossil sources or these other sort of veg spoils, if you like, using waste instead really presents a key opportunity to tackle these twin challenges of waste remediation and resource depletion. So one angle we've taken to look at this is actually using water as a reactant again, not through electrolysis as we had before, but actually through just heating water up under high pressure to make it much more reactive. So this is called hydrothermal processing. And this actually takes inspiration from natural processes that occur in the deep ocean bed, where carbon dioxide can react with water at hydrothermal vents. So these are areas where magma comes out at the Earth's surface. So although it's at the bottom of the sea, there are very high temperatures because we've got these vents with magma coming out of them there. So you might have temperatures of 200 or 300 degrees Celsius. You've got water at high pressure because it's at the bottom of the ocean. You get CO2 coming out of these vents, and you've also got mineral-rich sediments which contain a lot of iron, which can act as a catalyst to convert CO2 and water into organic products. So this gives us the idea of actually water under these conditions can be not the inert thing that just sips around as it does if you pour yourself a glass of water out of a bottle. It can become much more reactive. So that's something that we thought, well, can we harness that? The first thing to say is we thought we'd try replicating converting CO2 under these conditions, and we can. So I won't go into the technical details of this, but you can see we can successfully synthesize both small chain products such as methanol and also larger chain species that are more useful, for instance, for fuels and so on. You can see things like octanone, so a C8 species here, being produced simply only from water and carbon dioxide reacting together. So that provides a route to sustainable production, but we also wanted to use this technology more broadly. So we've looked at it for converting various different types of food waste. So for instance, we've taken spent grain, which is left over from the brewing industry, and we've turned that into different products. So we've turned that, for instance, into a solid carbon material that we can use as a catalyst or an absorbent, a solid absorbent to remove, for instance, pollutants from polluted water. But we've also produced liquid products from this. So oil type products that we can use to synthesize some of the products that we would currently get from fossil sources, from fossil oil. So what we've done is taking a waste product from food manufacture or beverage manufacture that would otherwise go to be thrown away, and actually made useful products from that. So clearly tackling this idea of the circular economy and sustainable production. The last example I think I want to give before I go on and talk a little bit about teaching is this idea of using not the chemical approach of putting everything in water and going to high temperatures and pressures and doing those sort of more conventional type chemical reactions, but a more biological approach of using black soldier fly larvae. So these are essentially maggots. We'll see a picture of them in a second. But using black at the top, you see the larvae from these flies. The larvae essentially do very little in their life other than eat, because the adults don't actually have mouthpieces. So what the larvae reserve in the adult for it to survive for the short period it requires to live as an adult in order to mate and ultimately reproduce. So the purpose of larvae is just to eat and generate fat. So that this fat ultimately could be a sustainable hydrocarbon source. So you can imagine a scenario here where what we do is we collect food waste, we feed the larvae on the waste, we then can then extract the oil, the fat from the larvae and turn it into useful materials. And we'll have a look at that in the next few slides. So when we say fat, it's probably worth clarifying what fat is in this context. So fats and oils are chemically triglycerides, and you can see what they look like in terms of the molecular structure here. They play a vital role in sort of body behavior, we on and so forth. So it really is, an essential and very, very useful product. The black soldier fly and the larvae are quite different from humans in the sense that they have a fat organ here that's dispersed throughout the body. So it's something called the fat body, and that only exists in insects. So it's something very, very different from the way fat is stored in humans. So in terms of these larvae and the fat within them, what's particularly interesting is the amount of fat that's there. So 30% of them by mass consists of fat. And this fat, when you look at the chemical composition of it, is very, very similar to that of coconut or palm oil. So you can see the chemical composition here based around the C12 fatty acid, lauric acid. That looks very much like something like coconut oil, which means we can potentially use this as a more sustainable replacement for the sort of products that we might make from those vegetable oils. But this time we're basing it on converting waste food into these fatty acids and then turn those into useful chemical products. And you can see here some of the products we're making. We're focusing on a variety of surfactants. So we start from the fatty acids from the black soldier fly larvae. We go through a variety of chemical reaction steps. So this is proper chemical engineering. And we end up with different surfactant categories at the end, ranging from soaps to some things you may or may not be familiar with. But if you have a look at the back of any consumer good that contains detergents, you can see various different things such as cocamide MEA there, sodium palmitate, lauric acid. All of these things are the sort of surfactants that we're making directly from the black soldier fly larvae's fat. So we're able to take the food waste, convert it via the black soldier fly larvae, and actually make the products that go into things such as surfactants and so on. Okay, I won't say too much about other processes we're looking at, other than to just give an overview. We're also looking at some more conventional things such as Fischer-Tropsch, where we're making liquid fuels from CO2. We have a pilot plant based at Sheffield that allows us to look at that at large scale. We're also looking at other areas such as synthesizing carbonates from carbon dioxide and so on and so forth. So this idea that I touched on earlier on of CO2 utilization as well as food waste utilization is something that's very core to a lot of what we do. So in the last 6-7 minutes, I just want to focus on how we would actually equip people as chemical engineers to tackle these challenges. How do we actually get them to develop the processes to turn waste into useful products and then hence feed into this sustainability agenda, if you like. So one of the key ways we do that is through a discipline that we'd call reaction engineering, which is about how we design and control reactors to carry out these reactions. And the important thing to say is, when we say a reactor, that doesn't have to be a big, large-scale industrial thing, such as you see on the left here. We can think about anything where a reaction is occurring as a reactor. So that can be biologically the stomach. We can think about reactions occurring in a leaf where you've got photosynthesis. That then is a reactor. And of course, the black soldier fly larvae, where they're taking food waste and turning that into fat, that is a reaction. So we can envisage them as a reactor. And we can take the same engineering approach, the same mathematical approach, regardless of what type of reactor we're looking at. And the way we do that is to define the system and then look at what goes in and what goes out. That's the key thing that chemical engineers do, really. It's actually balance what's going in, what's coming out, and using that to work out what's going on inside the reactor. So what do I mean by that? Well, let's actually look at a mass balance over a system. So we're saying what builds up in your system, in your reactor, is equal to what you put into the reactor, minus what leaves the reactor, minus the amount of that substance that's disappeared because it has undergone reaction. So that is just the very simple balance that we do to be able to analyze reactors and to design these processes. So I'll give you one very concrete example of that, which is a continuous stirred tank reactor, which you can see an image of on the right-hand side here. So this is a tank that has a continuous flow of material into it and out from it. That's why we call it continuous. It's also stirred, which is why we call it stirred. and stuff reacts in it, which is why it's a reactor. So it's a very clearly named system. So let's think about a mass balance over that. We said the material is continually flowing into and out from the reactor. So we're not expecting anything to build up inside it. So the stuff continually going in and out, so our accumulation term here is going to be equal to 0. We will define the amount of stuff we put in as the flow rate of that. So this is the molar flow rate. This is the amount of a material A that we're putting in per time. So this is just a symbol that means the amount of A going in per time. So we can then say the amount coming out is the amount of A at the exit from the reactor per time. So that's the amount of A at the inlet per time, the amount of A coming out at the exit per time. And then the amount that's reacted is going to depend on how quickly A reacts. So that's defined by the reaction rate, which we give the symbol R. And of course, the actual volume of material that we have. So it's how quickly it reacts multiplied by how much of it there is, gives us the numerical quantity for how much we lose through reaction. So that then is our materials balance over our continuous stirred tank reactor. So it's very, very simple, and we can rearrange that into an equation that we call the design equation for a CSTR. So that's the rate of reaction is what we put in minus what comes out divided by the volume. So how we actually use that is, well, we have to change the rate of reaction expression into a kinetic rate expression, which you may well be familiar with from chemistry. So that depends on the rate constant, which is K, multiplied by the concentration of our species A raised to the order of reaction N. The rate constant term K is related to temperature through what we call the Arrhenius expression. So you can see a temperature term here. So these relationships now allow us to relate reactor volume and temperature to the extent of reaction. So the amount of stuff that we start with minus the amount of our reactant that leaves tells us how much has reacted. So we can now relate all these different parameters together. So in the last 2 minutes, let's just do one example of actually putting this into practice. So imagine we've got a reactor where we want to achieve a conversion of 80%. So this might be 80% of our food waste that we're converting into useful products. If we start with a flow rate of that going in of 20 moles per second, a concentration of that of 20 moles per litre, and a rate constant of 0.01 inverse seconds for first order reaction, what volume of reactor do we need? So we said we've got this design equation for a CSTR, R equals NA0 minus NAE over V. We know, or at least we can define the conversion of our reactant A, which may well be some form of food waste. That then is what we put in minus what leaves divided by what we initially put in. So if we start with 100 and we have 60 coming out, that then would be 100 minus 60, which is 40, divided by 100. So that gives us a conversion of 40%. That makes sense. If you start with 100 and you end up with 60, 40% of it has converted, has reacted. That then allows us to make some very simple arithmetic substitutions. So you can see here that NA0 minus NAE is going to be equal to NA0 multiplied by XA from the conversion equation. So we can rewrite our design equation as V equals NA0 multiplied by conversion divided by rate. We know that rate is equal to the rate constant multiplied by concentration. That is the concentration of A at any point during the reaction, which will change, but we can relate that to conversion. So the concentration of A that we have is going to be the concentration of A that we had initially multiplied by 1 minus the conversion. So it's the amount of A that we actually have left. So it's the amount of A that has not undergone reaction. So the amount of A we have is what we had initially multiplied by 1 minus the extent of conversion of A due to reaction. So that then gives us an equation where we actually know all these parameters and we can put them in, do a very simple calculation and say that the volume of reactor that we would need to achieve this conversion of, for instance, our food waste would be 400 litres. And it's those sort of things that chemical engineers are doing and approaching in order to develop these processes to push forward the idea of sustainable production. So I just want to finish with just a summary slide saying that we're looking at new approaches to develop sustainable production within not just the food sector, but excuse me, that's my phone, I'll cancel that. But throughout the energy sector and all elements of production. But crucially, we have to think about sustainability, not just in environmental terms, but also societal and economic concerns. But the take-home message is hopefully that chemical engineers are making a direct and positive contribution to global sustainability across all of these areas. And with that, I'd just like to finish and pass back to the moderator.
Great. Thank you very much, Dr. James McGregor. Very great presentation. And I believe we got a lot of questions from the participants. But before we go into the discussion session, we'll hear a second presentation first from Dr. Warmadewanthi. The title for the presentation is The Rethinking of Plastic. Like what Dr. James McGregor previously said, that it's also related to the plastic management, and it's also related to the sustainable production. Now we will listen to the lecture from the Dr. Warmadewanthi. So without further ado, I'm gonna invite Dr. Warmadewanthi to please share your screen.
Thank you,
Yeah.
Nisa. We try to
Yeah, okay.
Screen.
In the meantime, I would like to invite all participants to please, if you have any question, you could submit your question into the through the link that has been provided by the committee, or you could also submit your question in the chat box, and then we will read later after the session. So please, Dr. Warmadewanthi, you have 40 minutes for the presentation. Now the time is yours.
Okay, thank you very much, Ibu Nisa, as a moderator for today. And good afternoon, Dr. James McGregor. Nice to meet you, even using the online platform. And I think this is not good afternoon, right? This is good morning in there.
Yes, it's good morning. It's around 20 past 9 in the morning.
Yeah, okay. And then for all of the participants, good morning, good afternoon, and also good evening also with some of you. So today I would like to mention what Dr. James McGregor previously also already mentions, but I'm mostly will be talk about the plastic because we are actually in Indonesia. We have a big problem about the plastic waste, and I will be focus on the rating of the plastic, especially for the plastic waste. My name is Warmadewanthi. You can call me Wawa, so easy to remember. And I'm from Research Center for Infrastructure and Sustainable Environment. And I also teach in Department of Environmental Engineering. Okay, so this is a little bit about my introduction. As a senior lecturer, I also have a background as the environmental engineer and also a chemical engineer. And then previously, mostly we are work with the waste management and also waste treatment. And also some that we are work, especially for my PhD, I work for the recovery of hazardous material, for example, from semiconductor or for fertilizer industry. Then we try to recovery of the phosphate and ammonium to become valuable material. Maybe this is a very familiar with friends in chemical engineering. And also right now we work a lot with some of the research center also from other country. that we are work a lot about the action plan for the plastic waste. So this is some introduction from me. And then the second one is maybe Dr. James McGregor. This is a welcome from us. Okay, welcome to ITS. As I mentioned by our rector previously, that this is the University of Hero, because we are built in 1960 in 10th of November, and this is the Heroes Days for Indonesia, because we have a big battle in Indonesia during that time, especially in Surabaya city. So it's why then our university known as a University of Heroes. And then this is our mission and vision. As a ITS vision, become innovative and internationally recognized research university. And this is the mission of the ITS. Of course, this is related to the technology and also related to the science and also related to the management system. And if you can see this building, this is the my office in the 5th floor and also 6th floor. This is the research center of the ITS. Hope that maybe next time some of Dr. James can come to visit us in ITS, and also some of the participants from other country. Okay, so this is the information about the ITS. Dashboard for Indonesia. So we have the SDGs report in 2020 that the position of Indonesia globally is in 101. And we can see from here, this is the dashboard for the SDGs trend. We can see from here. And for the SDGs number 12, actually Indonesia don't have enough data to show for this SDGs trend. Since 2080, I take a look the dashboard for Indonesia, and also 2019, also 2020 is similar. This is still unavailable of the information for the SDGs number 12. Okay, so but actually we already conduct many activity for fulfill the target for sustainable consumption and production pattern. Okay, and today I mostly will be talk with the goals number 12 number 5 about the reduce of waste generation through prevention, reduction, and recycling and reuse. This is the part that I will be talk mostly today. And as I mentioned to you previously, this is the performance indicator for Indonesia in 2016 and 2020. For the SDGs 12, responsible consumption and production, we still don't have enough available data for here. We just fill it in 2016 at that time about how much the solid waste generation, waste generation, and also SO2 emission. Okay, so I think in the next future, maybe if this indicator involved in our RPJMN or in our development goals, so it's why then we can get the data for the SDGs number 12 in Indonesia. Okay, then I will be jump to the explanation about what is the rating itself. Based on the definition, of course, rating is a think it again, okay, for everything carefully. Okay, for example, in here I take the example for rating of the waste, and also for the smaller scope is rating of the plastic waste. Rating of the waste aims to improve our effort at reducing, reusing, and recycling in order to decrease the amounts of the waste that ends up in a landfill. Okay, and we can see since 2017, actually in Indonesia, we fight with the plastic waste. You can see this is some of the report from the news that one of the beautiful island in Indonesia, this is my hometown in Bali, we fight with the plastic waste, especially in the beach during some season. For example, in February to March, we will have a lot of number of the waste in some of the area, especially in the beach, Kuta beach, that is very known very well. So we fight with this kind of the waste until now. So it's why then we need to think how we can dealing with the plastic waste, especially based on our goal for the integrated solid waste management. Of course, the top priority is try to minimize or reduce amounts of the solid waste that produce, not only plastic, but for all of the waste. Okay. And the second one is about reuse of the plastic, and then recycle, and the last one, disposal. But right now in Indonesia, this is vice versa, because a lot of waste usually will be dumped in the landfill. Okay, but just only a small amounts that recycle or even this reuse, and we don't have any habit right now to reduce amount of the plastic. Just only some people, maybe they already thinks about how to reduce amounts of the plastic waste and also waste. And based on this one, I also would like to share about the global problem about the plastic waste, especially why we need to rethink of the plastic. Okay, as I mentioned to you, since 2017, we are in Indonesia just known about some of the data that come up from the Jambek et al. In 2015, that we are the second largest contributor for marine plastic debris. And based on the data of the Geyer et al., this is globally, that the plastic production is increased time by time, and only small amount that recycling, and mostly they will be discarded into the landfill or burned. Okay, and some of the percentage will be incinerated. Okay, so this is the big problem, because we are know the characteristic of the plastic. Okay, they are very difficult to degrade and also will be stay very long time in the environment. So it's why then we need to think about how we produce and use of the plastic. And also based on the our work in data, Asia, especially China, Japan, and rest of Asia, we are produce and contribute 50% of global plastic production. So mostly produced in Asia, and then separate around of the country. Okay, around of the world. I mean, so that then it is one of the facts that we are stay in Asian continent. Okay, then based on this data also, again, we are jump to our country in Indonesia. How about the waste that we are produced in our country? You can see from this figure, this is one of the example for informal sector that we are also have some research for the informal sector, how they are dealing with the solid waste and how they help us to reduce amount of the solid waste dumped to the landfill. Okay. And this is about our country. Indonesia, with the population mostly is about 217 million of the people right now. We are generate a lot of solid waste in total. So here we can see from this figure that in total we are produce almost 64 million tons of the solid waste per year. Okay. But this is very interesting. The second one you can see from this figure. This is based on the data What a Waste by the World Bank in 2018, actually, about waste generated per capita, per person, per day in ASEAN countries. Okay, we can see here Singapore, they produce a lot of waste, almost 4 kilograms per person per day or per capita per day. Compared to Indonesia, we just only produce maybe around 0.5 to 0.7 kilogram per person per day. And also, we can see in here, other countries also, they have produced less of the waste generated per capita per person. This is very interesting. Why? Already mentioned by Dr. James previously that the economic have some impact, urbanization also have some impact, okay, and industrialization also have some impact about the waste generated. Okay, in Singapore, they produce a lot of waste compared to another country. We know that they are developed compared to us in ASEAN country. So this is the fact about the production of the solid waste. And after that, you can see from these figures again, the composition of the waste. And this is based on the World Bank data in 2018. And this is based on Surabaya data because mostly our research is in Surabaya city. And we conduct in 2017 that the data is mostly similar, that the plastic composition at that time around 13%. And still, the organic one that consists of the food waste is a lot. Okay, so we can see from these figures and almost a similar percentage of the composition. But when we are conduct the activity for analysis the composition of waste during pandemic, again, this is very similar. I think some research also come up with this kind of result that the plastic composition increased significant. In 2020, during June to July, in Surabaya, we have produced plastic waste around 22%. Okay, and of course we'll be also have some infectious waste because some of the like masks or latex that used in our daily life, so it will be also included in this solid waste. And again, we can see from this figure also, this is again based on the research. Sorry, this is the village, okay, in some area in Surabaya, and this is also the high complex or single houses in Surabaya, but they are mostly the middle to high income community, but this is mostly a middle to low income community. And we can see here that the polymer, the plastic polymer that they are produced, the composition is different. In a kampung or in the village inside of the city, they are produce a lot of sanitary. Okay, in here we can see this is because of the lifestyle is changed. And the second one in the middle to high income community, we are mostly produce of LDPI, and this LDPI mostly is single-use plastic bag. So this is very bad for the environment. Okay, because we are produce a lot of the plastic that is very, very difficult to recycle. Okay. And then after that, as I mentioned to you, we are generate the plastic, but on the other hand, some industry also import of the plastic from other country. And this is the fact in, especially in ASEAN countries. And we can see from this figure again, that since China banned import of the plastic waste from another country, then Malaysia, Vietnam, and Thailand, see, this is a little bit increase of the import of the plastic from other country. And this is based on the table data that Indonesia is also included in as important for the plastic waste. Sometimes people will be asking me why we need to import the plastic. On the other hand, we also produce of the plastic waste a lot. What happened? So this is, I will be answer after this explanation, because we have the focus of the focus of group discussion with the many stakeholders. We talk about the plastic waste, especially why the industry still import of the plastic waste. On the other hand, the informal sector, for example, waste bank in Indonesia, and also large scale recycling enterprises, they have produced a lot of plastic waste. Okay, and then we can see from here, this is several cases, maybe already know very well in the newspaper also. This is the village near of Surabaya city itself, that the people in here live because of the recycling of the plastic residue from the industry. But right now they already clean up and already stopped to do like this kind of activity. This is of course is very dangerous for their health and also the environment. Okay. And then this is the fact for Indonesia. As I mentioned to you, in 2015, Jambek et al., based on their data, they mentioned that Indonesia is the second largest contributor for the plastic waste in the ocean. So this is based on the data of the World Bank. Okay, World Bank already mentioned that in Indonesia itself, 80% of the plastic waste came from the land, because we have unmanaged of the solid waste every year, and also 45% of the solid waste just burn or illegal dumping and also throw to the river. So this is why we can get a lot of the plastic waste, especially in the ocean. This is the case in Indonesia, but right now we still doing some research for case of the Surabaya city itself. how much the plastic that come to the ocean, especially from Surabaya side. Okay. Here, this is the picture that taken by Ibu Nisa, I think this one, because Ibu Nisa also worked together with me about the plastic waste. This is in area of the mangrove in Surabaya. So this is actually a very beautiful places, but of course we find again the plastic waste a lot. And then in here, the position, the geographic position of Surabaya, actually we are in the downstream area. And some of the plastic waste maybe not contribute by Surabaya people, but maybe come from another a part of the East Java, because we are in the downstream. So maybe we will have a contributor from the upstream area, especially in this delta area. So this is the pictures of Surabaya right now. And how we can dealing with this one? Okay, I will be jump to the SDGs itself. Okay, we can see from this figure actually, we can think about the plastic waste, as I mentioned by Dr. James previously. Dr. James mentioned a lot of the example for sustainability, especially, and also for the responsible consumption and production. Actually, this visualization map I take from UNESCO, and it can be used for many different purposes. And I think in here I use for the rating of the plastic waste. This is interlinked between the SDG number 12 to another SDGs. For example, in here, okay, if we take a look for the plastic waste, especially for rating of the plastic waste, several of number of SDGs involved. For example, SDG number 3 for good health and well-being, number 6 for the clean water and sanitation, number 11 for sustainable cities and community, number 12 for responsible consumption and production that we talked today, and number 13 with the climate action, and number 14 life below water, and also number 15 life on the land, and also added again by number 17 about the partnership. Okay, so many SDGs that interlink it with this plastic waste problem. If we start with the reduction of waste, especially waste reduction and prevention of the plastic and hazardous chemical that come up with goals of 12 number 5. So it's why then they will be have the interlinkage with the protect of the marine and terrestrial ecosystem. They also have interlinked with the animal habitat. This is the goals that included in number 14 and also in the 15. Okay, so this is all will be interlinked, and after that also can increase the productivity of the soil and also productivity of the fish, and this is will be interlinked with the SDGs number 2. So this is why we need to think one step, okay, small step that we are doing, they will be have some impact on another goals for the SDGs. So this is the message that I would like to share to you. The small step that we are do will be interlinked with another SDGs goal. Okay, so this is for example, just only for example. Other things that we also can use like this one, because a lot of visualization map can show the interlinkage between one target of SDGs to another target of SDGs. And then who will be responsible for the plastic waste production, especially, and also consumption? Okay, first, of course, is industry. Okay, with the extended producer responsibility, actually Indonesia already started in 2008 about Solid Waste Act at that time, but then we have the new one about the roadmap for the solid waste extended producer responsibility from producer in 2019, that the producer need to be responsible for post-consumer of their product. Okay, and then other than that, how about us as a consumer? Okay, we try to use less single-use plastic or packaging and try to implement it, reduce, reuse, and recycle. And the most important thing in Indonesia, I think, the separation of waste, because we are in Indonesia don't have a good habit on separation of waste itself. And of course, for the government, they have responsible to provide of infrastructure and implemented of law enforcement and also environmental education. This is, we think that who will be responsible for the plastic waste production and consumption. And this is the policy in Indonesia. Actually, we have the National Action Plan to reduce about the plastic waste that goes to the marine ecosystem, because as I mentioned to you that we are the second largest contributor for marine plastic debris. So the government has the National Action Plan with the 5 strategic. The first one, of course, is change the behaviors of the people. And the second one, reduce of the land-based leakage, reduce of the sea-based leakage, enhance law enforcement and financial, and also conduct of the research and development. And the target goals of Indonesia in 2025, we try to reduce 70% of the plastic waste that goes to the ocean. So this is a big and ambitious target for Indonesia. So it's why then plastic become a very hot topic of research right now in Indonesia actually. And this is what I mentioned to you previously, that if we try to rethink of the plastic, and the responsibility is also in the producer. So the Ministry of Environment and Forestry already have the regulation about the roadmap for production, how they can be responsible for their waste. And we can see from here that some of the manufacturers, for example, they will be prohibited to using PET, PE, PVC, PP flexible, and other type of the plastic. And retail also will be prohibited to using single-use plastic. And food and beverage also, there will be restriction to use a single-use plastic, including utensil and also paper for food and the beverage. So the goals will be shown in 2029 that 30% of the waste need to be reduced from the this regulation, extended production responsibility. Okay. And what is the action? In the national level, this is the action that already conducted by the government in Indonesia. I'm divided become 4 different action: reduce, reuse, and recycle. As we are talked today about goals 12 number 5. Okay. Then the second one is clean up, and then alternative to the plastic. This is already mentioned by Dr. James previously. They tried to find another way to produce biodegradable of the plastic. And also the last one is monitoring and research. And as I mentioned previously, we are also conduct the monitoring and research in here, especially for marine litter monitoring. Okay. And but for me today, I mostly will be talk for the first part about reduce, reuse, and recycle of the waste in terms of our city in Surabaya, because I come up to a smallest scale right now in Surabaya city. Okay, so Surabaya known as a second largest city in Indonesia, and our population almost 3 million people in here. And if you have the opportunity to come to Surabaya, actually Surabaya is very beautiful city. Okay. And in here we can see that this is my research center, or our research center. In here today we talk about the infrastructure and sustainable environment in ITS, as mentioned by Dr. McGregor previously. The sustainability not only environment but also social. And in ITS, for our research center, we also work with the environmental sustainability and also social sustainability. And this is the roadmap of the research. We hope that also can work together with you, Dr. McGregor, because some of the research maybe can be have some intersection for the research. For example, this is the research in our research center, and we have for climate change, pollution control, built environment, protection of natural resources, and also efficiency use of resources that we are talking today. So the part of that we are talking today is about solid waste management and a part of the circular economy also. So this is our research center in ITS. Okay. And for our research itself, we also ask the student, you can see in here, and I don't know why it mostly is the girl, okay? We work together with the informal sector, try to separate the waste, try to find the composition, which waste that can recycle, especially for the plastic waste, because we know that the plastic waste also can be recycled and also can be used as a source of energy. For example, for the RDF, okay, we can use some of the plastic waste and also some of the food waste that can be used as a raw material for the refuse dry fuel. Okay, and then other research that already still continue to conduct until this end on 2021. We work together with the UNESCO and also IGES and Leeds University, try to come up with the action plan for the plastic waste reduction in several of the city in ASEAN country, from Thailand, Malaysia, Vietnam, and Surabaya in Indonesia. So we try to scale up and tackle about the problem, especially for the marine plastic pollution in Asian city. And this is a part of the SDGs number 11, 12, and 14. And we still conduct this kind of the activity until now. Okay. And based on that research also, we are now the stakeholder that responsible for plastic waste management in level from national and also level of the local government in province and also the local government in Surabaya. This is different from one city to another city, because, for example, in the local government in Surabaya, we have 3 different agencies that responsible for the waste management and including for the plastic waste. The technical one is the cleansing agency, and other than that, for the monitoring is environmental agency, and for the planning is the regional body for city development planning. Okay, and then this is our solid waste, not only for the plastic. Previous one I showed the composition, but this one is generation of the solid waste. Time by time always increase, but during the pandemic, okay, it's a little bit decreased, okay, because we are work from home, we are study from home, so some is go outside from Surabaya city, so it's why then generated of waste is a little bit decreased. But I think right now already back to the normal, because we already start our daily life like a previous one. And this is the material balance of the solid waste in Surabaya. Okay, and mostly goes to the landfill. Even we have the recycling also, and we have the waste bank. We also have the composting center, try to reduce amount of the organic waste. But for the plastic waste itself, mostly we are depend on the waste bank activity, informal sector, and also the recycling center. Okay, and then this is the composition, as I mentioned to you previously, that 22% is the plastic, okay, and then a lot of single-use plastic we find in Surabaya, so it's a little bit difficult to recycle, okay. And this is what Surabaya community or governments or academic, all of the stakeholders already done for rethink of the plastic, okay, especially for the plastic waste. This is the first one for the example. This is community involvement by the waste bank. Although right now the reduction of the waste is not large enough, but we can see from here that several people, and especially for the mother, they really like to separate the waste, have the social communication together, okay. And this is the closed loop system of the plastic waste recycling in Surabaya. We are conduct based on our research. And a waste bank unit, usually they will be sell to small scale enterprises, because the price is a little bit higher compared if they are sent to the central waste bank. And then other than that, from the small scale, they will be go to large scale and then go to the recycling industry. And this is the mapping that show the active of the waste bank before the pandemic COVID-19. We have 374 of the active waste bank in Surabaya. But then during the pandemic, several was closed because the restriction from the government. But right now, I think they already operate again and try to again involve in the recycling activity, especially for the plastic waste, because the percentage of plastic in here a lot, okay, for recycling. And what is the challenge? The challenge in here is try to keep the spirit of the community to involve on the recycling of the waste, especially for the plastic waste. So this is the challenge for us, especially how to maintain the spirit of the people, voluntary to collect the waste, separate the waste, then sell the waste to small scale enterprises or to the central waste bank. Okay. And the second one, this is a story that, not the story, actually this is the result of the research also, because we are conduct the research in this area. This is very near to my home. And we can see in here, the fishermen in the eastern part of Aya, they mentioned to us that they can collect 30 to 50 kilogram per week of the waste, okay, especially for marine plastic, and they can earn money a lot compared to as a fisherman. So this is a case in Surabaya city. Okay, so we are proving that a lot of the waste that go to the river and then goes to the ocean in this area. The second one, increasing of recycle rate by TPS3R and informal recycling sector. You can see from these figures, this is some activity that already conduct in Surabaya, try to formalize the informal sector and also try to formalize the informal recycling center in Surabaya city. And the ones that I would like to answer the question previously, why we still import of the plastic in plastic. Based on our discussion with the industry, the balancing of the supply and demand in Surabaya city itself is not good enough. Okay, so the industry need a lot of plastic, but on the other hand, they don't know where they can get the plastic with the good quality, because in Surabaya actually we will be mixed our waste, and it's very difficult to recycling because the industry need to clean up first the plastic waste before they are using. So this is the drawback of work together with the informal sector and also the waste bank. So it's why then we try to find how the good way to balancing the supply and demand, so industry maybe can reduce amounts of the plastic import from another country. And other than that, the increase of recycling rate by innovation solution, if you go around of Surabaya by using a bus, you need to pay the ticket by using the plastic. Okay, so 1 year we can collect about 41 tons per year of the plastic and then sell to the industry. Other than that, the regulation and involvement of institutions try to reduce amounts of the use of the plastic in our daily activity. And number 5 is innovation, research, and development. This is, for example, in our research center, the edible film as a material that can use of wrapping for food made from chitosan and food waste. Okay, for banana skin, especially this is developed by our researchers, especially from chemical, from chemistry. And other than that, action plan for plastic waste and then monitoring of leakage of the plastic waste. We also have the alumni of the ITS, the recycle of the plastic. You can see from this website that they have a very good example for recycling of the plastic and already sent also for export to another country. We are not believe that this come from the plastic waste. I also have some at my home. Okay, this is the last one that I would like to finish the talk, maybe already more than the time, sorry, that we have the challenge for the plastic waste management in the COVID era, how we can dealing with this one. Of course, we need to have the guideline during the pandemic, especially for recycling, because they have a big problems during the pandemic, how to recycle, how to have activity for recycling. And also solid waste system must be adapted to any events or any problems in the future that might already occur. So this is the last slide, and I hope that you can answer my question about one word to describe what I mentioned previously, the thing of the plastic. Okay, thank you very much. Oh, sorry. Thank you very much, and I give it back to the moderator, Ibu Nisa. Thank you.
Great, very insightful presentation from Dr. Warmadewanthi related to plastic. Now we go into the discussion session, and we already received some questions from our participants. But before that, I just want to inform everyone who participated in this webinar. So we have participants coming from various countries. So we have a large number of participants coming from Indonesia, of course. And then we have also some participants coming from others ASEAN countries, from our neighbor countries, from Malaysia, and also colleagues from the Philippines. And also we have also participants from the Netherlands. I also see some participants from Germany. Yeah, so I'm gonna read out the first question from Tito M. Clerigo from the Philippines. So the question is this question is directed to both Dr. Rama and also Dr. McGregor. So the question is, the current plastic waste, the single-use plastic waste that we have today, it's really dangerous for the marine environment. And there has been also the plastic waste that is labeled as oxo biodegradable. And does it has the same effect with the old plastic waste, like the common plastic waste, or it also have a huge different impact to the environment? And the second question is, could we actually implement to ban the use of the single-use plastic bag in our community, and also to use the eco bags in our community? So please, maybe, yeah.
Yeah, I mean, I can start. So obviously, while I spoke excellently on the topic overall, as I mentioned as well, we've got a large interest in plastic waste and single-use plastics and so on at Sheffield as well. And I think there were some really interesting points in that question that show a lot of the complex interlinkages. So for instance, there's a question about should we get rid of single-use plastic bags? And speaking from a UK, well, it's in England, it will be slightly different definitions to the UK, but in an English perspective, we a few years ago got rid of supermarkets being able to give single-use plastic bags. And one of the things you could then buy was a much more substantial bag, also made of plastic. People then actually ended up consuming more plastic through buying the thicker plastic bags that could be used multiple times and keeping them at home. There were also issues with, there was a big trend towards paper-based bags, which reduces part of the problem with plastic, but part of the manufacturing process for that was actually more energy intensive. So it links into issues with not necessarily plastic waste, but with climate change. So there's lots of interlinkages there that trade off against each other. There's a question about banning single-use plastics as well. And I think it's important to remember all types of plastic are really valuable and useful for lots of things. The plastic plays a huge role in limiting food waste by extending the length of time we can have food and so on as well. So we've got to think about the benefits of plastic, but it's how we make it more sustainable. The biodegradation question was interesting insofar as it was about oxy biodegradable, and we've got to make sure that if you're putting something in landfill, when it's underneath the ground, a lot of the conditions can be almost anaerobic. So if you require oxygen to degrade it, even if it degrades in the presence of oxygen, if it's under a thick layer of ground and oxygen isn't getting in, it's still not going to degrade. And genuinely biodegradable plastics is a challenge to make plastics with the same material properties that we currently have. So if we want to use them for all the applications that we have, all the way from, we've talked about plastic bags, but all the way through to things that we use in building houses and construction and so on, we need a whole range of different plastics. And if you want them to have biodegradable properties, we still have a bit of technical development work to produce genuinely degradable plastics with the same range of materials properties as we get from conventional plastics. So I think I haven't necessarily answered a question there, but I think it's good at highlighting the interlinkages and complexities where one thing comes up against something else. So something that looks good for reducing waste might actually make climate change worse, and how you balance all those different concerns is a really interesting question. But yeah, we're pushing forward and making those developments and developing new plastics and coming up with approaches that work, taking into account not just the waste, but the bigger picture as well.
Yeah, so you mentioned regarding the needs of oxygen in the biodegradation processes for the oxo biodegradable. Does it mean that if the plastic is end up in landfill, that will be a challenge when the plastic itself requires oxygen to degrade it?
I think we should be aiming to not have anything end up in landfill. That should be the ideal goal. It's we heard about plastic recycling. Plastic is a source of carbon that we can use to make useful products from. If ideally plastics, again, if that can be recycled in some way, that should be the aim. The aim should be not to think about stuff being disposed of, and taking that resource out of the economy. It should be, once that carbon is in the economy, it should stay there and be reused in some way. I don't know if Wawa wants to say a little bit more on that, because that's something you spoke about in your presentation.
Yeah, Dr. Rama?
Thank you very much, Dr. James. I think it's already answered the question for the participant, because as Dr. James already mentioned, yeah, we have like a circle problem in this using of the plastic, okay? Because on our daily life, I think we use a lot of plastic in our daily life since 1950, and it's always increased time by time. And right now, people mention about how we are dealing with single-use plastic, because it's very dangerous to the environment also. And then for this one, because I think I will be answer both questions, because they also are asking about single-use plastic. Is it possible that we are banned to use of the single-use plastic in some area in Indonesia? As I mentioned to you, right now we have 27 of the local governments, especially already ban using of single-use plastic. And right now we still have some conduct of the research. We will be analyzed with the implementation of the ban single use of the plastic waste, how will be have an impact on the composition of the waste. So we still conduct this kind of the research right now, try to analyze the effectiveness to implement it of this single-use plastic ban, or a ban of single-use plastic, okay? So on the other hand, like Dr. James already mentions that for the plastic itself, for the biodegradable plastic, for example, it's already mentioned, we need that there is no need to dump again in the landfill, because we already know that this is a danger to the environment. So it's why then we need to recycle to become a new product. For example, right now, so many activity already conducted for recycling of the single-use plastic. For example, they're using as a construction, or they're using as a part of the making a road, for example, because in Indonesia we have this kind of the activity, try to use for become a material for the road, and also for material for construction. But of course, they mentioned that they will have some impact. For example, because of they maybe will be release of the microplastic to the water, okay, or they will be released to another pollutant to the another medium of the environment. But we still try to conduct this kind of the activity, and also conduct the research, because we are know the dangers to use a single-use plastic, and if they are always increase time by time, what will be happen to our environment especially. So our part right now as a consumer especially, okay, we can use very wisely, try to recycle of the using of the plastic, not only for single use only. Okay, so this is maybe my opinion, Ibu Nisa.
Yeah, perfect. So we go on to the second question. It's still related to plastic waste. We got a question from Stefan Kenter from the Netherlands. So it seems like Western countries sell their non-recyclable plastic to developing countries. And the problem in developing countries is that the countries do not have, they don't have resource to deal with the recycling process. And they also have problems related to the increase of the number of waste generation in general. So how can this export be prevented so that the Western countries need to take action well?
Yeah, I think that's a very, very fair and very valid point. And I think that, we both spoke about viewing sustainability as the 3 pillars. And one of those was societal sustainability, and in being as a global citizen, taking waste from one country and just transporting it to another country is not being socially responsible in that sense. It is not necessarily feeding into that part of the sustainability agenda when we view that as is all as global citizens. So there does have to be, that is something that does have to be addressed. And of course, shipping something across the world has carbon emissions associated with it is not good for the environment either. So it is another angle where we need to look at how to actually, again, comes back to this idea, things can be recycled as a resource in the place the waste is generated. It resolves that problem. But while we don't have those technologies yet, these are things that have to be addressed, at the state of national government level back through policy, but there has to be pressure from public in order to influence national government policy in these places, and such as Britain and so on as well. But the goal is to be able to act so that people don't think, how do we get rid of this waste? It's how do we reuse and recycle and extract value from this waste? And if we can shift that mindset, hopefully to some extent, that eliminates the source of that problem that currently exists.
Yeah. Dr. Roma, do you have something?
Yeah, I would like to add some comment from Dr. James previously, because as a global action, we have a lot of global action try to reduce amounts of the export or the import of the plastic. And as Dr. James already mentions that where they are produced or where the plastic produced, I think it's the place that they can be recycled. But the problem in developing country, like you mentioned in the question, okay, in Indonesia, for example, we just have a big events together with a big company for especially for food and beverage, and they already mentions that the problem in Indonesia actually for high value economic of plastic, for example, PP and PET, they already have some market to recycle, okay. But on the other hand, for the low value of the plastic, for example, single-use plastic is very difficult to recycle. And in Indonesia, actually, we don't have any standard for packaging. Okay, we don't have any standard for the packaging. We can use every different type of the plastic for the packaging, even for difficult to recycle, because the different type of the plastic, maybe Dr. James knows it very well, because in the chemical engineering, if we have the different polymer, so the different treatment process is needed for recycling. And sometimes we also cannot recycle it because have the standardized for packaging. For example, as I mentioned to you previously, extended producer responsibility. This is a part that the producer need to use some of the packaging, not for all, like a styrofoam, they cannot use it again in the future. and some of the plastic they also cannot use again as packaging. So it's why then this is a problem in our country. I think in some country like in Japan, as I know, they have the standardized for the packaging. So people will be easier to treat it of the waste or especially for the plastic waste. So the most important thing is also the standardize of the packaging, especially for the plastic. Ibu Nisa, could you hear me? Yes. Could you hear me? Yeah.
Yes, yes, very clearly. Yeah. Maybe I could add another question from one participant from Nima Sakrida. So the question is, what materials can replace plastic, especially for industry? Which of course the material is environmental friendly.
So there's different angles to that again. So one of those is certainly actually making plastics from different sources. So we heard in Wawa's talk of making plastics from chitin, which is a biopolymer that you get in the shells of crustaceans, so on, but also in black soldier fly larvae and the exoskeleton of those you have chitin. So the thing I mentioned there, you could extract chitin and turn that into a plastic from an alternative source which is more sustainable. So if we're looking at it from the point of view of wanting to reduce fossil use, there are lots of people looking at how to develop new plastics, but this is where the material property problem is even more acute, in the sense that developing bioplastics made from renewable biological sources with the range of materials properties, we're even further away from actually being able to do that well than we are with other replacements. I think we have to remember that we do need something that fulfills the property of plastics, and plastics fulfill that very, very well. I don't know that we want to reinvent the wheel and come up with another material, because we want to come up with another material that has the same properties as plastic that we can use for all the valuable uses we currently have. It is just going to be another polymeric material at some description. So it's not trying to eliminate plastic. Plastics are the development of modern economy and modern society is depended on plastics, and it will continue to do so. It's how we do that sustainably without the waste, and alternative sources of plastic, and therefore being able to make those with the right properties, which we can't do yet, but things like looking at chitin as a source for that, and then, not to bang on about this, but then recycling those is the solution. It's because we can't just go, what other material would we use? Because we're just going to have another material that has, by definition, similar properties because we're using it for the same thing, and invent a new problem. It's recognizing the important role plastics have, but saying, why do we waste so much of it? Get rid of a lot of the single-use stuff, recycle what's left, but actually have materials that, as was said, can be recycled. If we have mixed plastics and we've got PVC in there, the chlorine can poison a lot of processes and make that very difficult. So it's actually thinking about what materials are out there and having the right materials out there for the right purpose that we can then bring back and recycle. So it's thinking about complete wholesale replacement of plastics, I think, is the wrong angle. It's thinking about it much more holistic.
Dr. James, I believe you're muted.
Yes, I was just handing over if Wawa wished to add anything to that.
Oh yeah. Dr. Wawa, do you want to add something?
No, I think it's already answered by Dr. James previously about how to change the plastic in industry. But Dr. James, I talked with some friend in here because you
Dr. Wong,
mentioned
maybe
about the BS. Could you
Dr.
hear
Wong,
my
maybe you could turn off your camera so you could have a stable connection.
Okay, can you hear? Could you hear my voice?
Yeah, we could hear you.
No, not yet. And Dr. James, this is very interesting talk, as I mentioned to you, because we are also have this kind of the research, but for the organic waste, especially for the BSF. But we are not continue with the product that I give it back to you.
Yeah. Okay. Since you are mentioning BSF, I also have a question in mind related to the presentation from Dr. McGregor. What are the key parameters for having a good BSF product during the process?
So I didn't catch the end of that. You asked for the key parameters for what, sorry?
Yeah, the key parameters to have a successful BSF products.
So, I mean, I think that's really useful to hear as well, that it sounds as if there's BSFL processing going on in Indonesia as well. In terms of key parameters for a process, I think one of the good things is that the larvae essentially will eat anything. They're non-selective in the organic material they eat. So that provides lots of advantages in processing. The amount of fat they generate and the composition of that will vary slightly depending on their diet, but they will essentially, to all intents and purposes, eat almost anything. So that lack of selectivity is fantastic. You do also have to look after them, but what I think is people have done with them previously is use it purely from the waste remediation angle. So use it to consume as a source of getting rid of organic waste. And then they might be used, for instance, to supplement as a protein supplement for animal feed and applications like that. I think what we are doing is slightly different in going, yes, the protein within them is great for animal feed, but you can then look at the other major constituents, which would be things like the chitin from which we get chitosan, which was mentioned as a feedstock for bioplastics, but then the fatty acids, which are less useful for a feed additive, are actually a really good feedstock for the current chemical industry. So it's that aspect of actually making the most use and extracting the most value from these things, I think is what we've been doing a little bit differently, rather than just going, it's just a means to get rid of waste. Don't just think of it as a means to get rid of waste. Think once you've done that, what can you do that has the most value and the most benefit with the end product of this? And the end product of it is the larvae, ultimately. And that's what we're doing, putting through the chemical processing. But in terms of what the important things for a successful processing are, I say they'll eat anything, but obviously some minerals and so on to actually keep them healthy is important.
Yeah, it's interesting. I'm also aware that there has been many small businesses started in Indonesia. So they start to utilize the food waste and then they turn it into the BSLF. And the first is they try to tackle the first issue, which is the huge amount of the food waste produced, and then the second they try to ask the people who are with less skill to join them, and then they could learn together, and then they start to produce BSF, and which could give a benefit in terms of income, also in terms of knowledge. So we got a question from Natalie Farbarova from the Czech Republic. This question is directed to Dr. Warma. So Dr. Warma mentioned previously that the volume of the waste produced during the pandemic is lower in the case of Surabaya, but she has the opposite feeling because she thinks that mainly when all the restaurants and cafes are closed, just enough people are buying takeout food, and then they use single pack. So many people ordering food home instead of cooking, and then it produces a lot of plastic. Dr. Ahmad, what do you think with this situation, considering that some people really don't prepare their food at home and then they prefer to have takeaways, and instead of having more organic waste, they produce more plastic waste?
Yeah, Ibu Nisa, I think this Natalia, this is my the first time when I think about this pandemic. I think also last year, right, Ibu Nisa, we try to we stop to work from office. We just work from home, and everyone study at home. So it's why then at home, yeah, we are per kilogram per person per day in my home. Okay, but on the other hand, in the case I could I share my screen, Ibu Nisa?
Yeah, I can see your screen now.
Yeah, this is in the case of Surabaya. You can see from the household, this is the household solid waste. This is on I think January, February, March, and also indeed this area. But in some area, such as near to our campus, because so many people is, for example, stay in the boarding house, and then the student go back to of waste, I think it's mostly similar. But why the waste in Surabaya decreased significantly because of this activity actually? Because in Surabaya, the waste is also come not from at that time. You can see from here, this is in the campus, okay, in the university, as I mentioned to you. This is ITS. The ITS production of waste at that time decreased. Yeah, because mostly this also produced from the non-residential activity. Okay, so it's why then we can see here, this is the mall. Okay, the big mall in Surabaya at that time, amount of waste is very attention to you. Previously, our composition of waste for the plastic just only 17%. But right now, they are increased to become 22%. So yeah, we are producing.
Dr. Warma, we are losing your voice.
Ibu Nisa, could you hear my voice? Ibu Nisa, could you hear my voice?
Yes, we hear your voice.
Okay. So this is my answer.
Hear your voice.
Yeah.
Yeah, Dr. McGregor, maybe you would like to add something related to the case in Sheffield, maybe, or your neighboring area.
Yeah, no, I mean it's a good question. I think what's highlighted there is it depends on the area you're looking at. So looking at the university, you're seeing a reduction in waste, but the question has obviously seen an increase in where they live, and I think you'll see very different impacts in different parts of a country. So in Sheffield, we will see, for instance, that the city centre is very, very quiet, and from the train station around the offices and banks and so on, the questioner highlighted lots of takeaway and so on, people having coffee, grabbing something in plastic for lunch and so on. That's not happening in the city centres, but in the more suburban areas where people are working at home, you're seeing footfall and potentially, I guess, yes, potentially greater waste in some of those areas where people are working at home that would normally be based in the city during the day and so on. So it's very much not an even response. And I think working out what the overall impact has been is something that will be done afterwards. But you do see that patchiness. I think it's quite interesting to see how different areas are affected. But again, it's this greater balance. If people aren't necessarily going out and driving to work or driving to a supermarket to get food, that's potentially beneficial in terms of reducing travel. But then we're having a lot of stuff shipped in giant cardboard boxes and plastic boxes as stuff gets delivered to people, which is a negative. And that's why actually looking at big picture things, looking at full life cycle analysis, and actually drawing your system down to include as much as possible so as you're getting the true picture of what happens is really important, rather than just looking at some isolated area, whether that's a university or a town or a city centre, or even looking only at the impact of personal travel. Everything is interconnected and fits in. So we've got to, people with different skill sets from different disciplines have to work together and pull that knowledge and that skill set in order to actually even get a picture of what is happening just now, never mind deciding what we do about that to make it better in the future.
Yeah, thank you, Dr. Rama, and also Dr. McGregor for the response. So we are running out of time, but we got our question answered. I thank Dr. Rama and also Dr. McGregor for the great presentation, and also thank you for responding to the question from the participant. And I will hand question back to the committee.
Okay, thank you very much, Dr. McGregor and Dr. Warmadewanthi for the excellent lecture today. And thank you, Ms. Nisa, for conducting this amazing session. Please give applause to our speaker and moderator by using the Zoom reaction feature. Furthermore, we would like to present a certificate awarding to both of our speakers and also our moderator today. First is the certificate presented to Dr. James McGregor. Next is the certificate presented for Dr. Warmadewanthi. Last but not least is the certificate presented to Ms. Ainul Firdausi Nisa. Once again, thank you very much to Dr. McGregor, Dr. Warmadewanthi, and Ms. Nisa for your availability on today's guest lecture series on SDGs. Before we end our lecture today, we invite you all participants, as well as the honorable speaker and moderator, to take a group photo. To all participants, please open your camera. Now we will wait for a few moments until participants open their camera. Okay, since we have 2 slides, so please keep your smile until we finished our group photo. Now I will count 1, 2, 3. Once again, 1, 2, 3. Okay, now we have finished our group photo. And then for the participants, please fill the feedback form through the link bit.ly/feedbackgls that you can also see on the Zoom chat room. The deadline for filling the feedback form is 1 hour after we finish this session. We want to remind you that the participants who will get the stamp is participants who come on time, join this event until the end, and also fill the feedback form. Finally, we have reached the end of today's guest lecture series, and we sincerely apologize for any mistakes we may have made in presenting as Masters of Ceremony and Committee. Thank you very much to our honorable speakers, moderator, and all participants for the attention and cooperation. We will see you in the next guest lecture series on SDGs next week, as we will have one session on Tuesday with a topic, The Light of Cebu Experience, a Nexus of Education and Climate Action, that will be delivered by Associate Professor Midah Kabir from Cebu Technological University, and also another 2 parallel sessions on Wednesday. The first session will have a topic, Rural Electrification in Sub-Saharan Africa, Lesson from the Field, and Harvesting the Sun, Unlocking the Door to a Sustainable Living, that will be delivered by Professor Patrick James and Dr. Ruri Agung Wahyuwono. And for the next parallel session is the topic, Water and Wastewater Engineering and Resource Efficient Sanitation, Planning with Focus on the Global South, that will be delivered by Dr. Duratul Alim Talibon and Ms. Ainul Firdausi Nisa. Thank you very much. Good afternoon, and wassalamualaikum warahmatullahi wabarakatuh.
Thank you. Thank you, Dr. James. Thank you
Thank
very
you.
much.
Thank you very much.
Yeah.
Thank you, Dr. McGregor.
Thank
Thank you,
you,
Bu Awa.
Thank you, Paufi. Thank you.
Thank you.
Thank you, Bu.
Yeah,
Bu
thank you,
Arman.
Rita.
Thank you, Bu Nisa.
Thank you. Bye.
Bye-bye.
Thank you to our speaker and our moderator and also our participant, and allow us to end this session in 3, 2, 1. And Mbak Vivi, you can end this session. Thank you.